Good evening, everybody. My name is Ferhan Mazher, and in this video, we are working on the solution of the course book of the Pure Maths 1. We are working on the exercise 9B. This is our third episode on this exercise. The topic of this exercise is finding the constant of integration, and the topic of the chapter is integration. And in this video, we are starting from the question number 5. Let me show you the question. First of all, the question number 5 is given here. So you can see the question number 5. A curve is such that dy by dx is equals to 5x under root x plus 2. Given that the curve passes through the point 1 comma 3, find the coordinate of the curve, the coordinate of the tangent to the curve when x is equals to 4. So this is the question, sir. Dy by dx, in the first part we have to find the coordinate of the curve. The curve passes through this point. So x and under root x, that will become x raised to power 3 by 2. So dy by dx is equal to 5x raised to power 3 by 2 plus 2. So I will integrate both the sides. So integrate both the sides. So here you will have y. Here the power will be increased by 1 when you increase 3 by 2. When you add in 1 in it, so you will have 3 by 2 plus 1. That will give you 5 by 2. So with the same number you have to divide. Plus the integration of the 2 is 2x and plus c. So you will have y equals to 5 by 2 means 2.5 power, which means a square and a half power. So square and a half power means under root x. So x square under root x. Okay, 2, 5 cancel. So you will have 2x square into under root x plus 2x plus c. So because this curve is passing through this point 1 comma 3. So in the coordinate of this curve, in the place of the x you will put 1, and in the place of the y you will put 3. So you will have in the place of x 3 equals to 2, 1 square under root 1 plus 2 into 1 plus c. So 3 equals to 2 plus 2 plus c. So that c will be equals to 3 minus 4. The c is minus 1. So the equation of the curve will become y equals to 2x square under root x plus 2x minus 1. So this is the equation of that curve, and this is the first part of that question. Then in the second part of that question, they ask you to find the equation of the tangent when the x is equals to 4. So because I know dy by dx, in that I will put the x equals to 4, and I will get the gradient of the tangent when the x is equals to 4. So in the dy by dx expression, I will put x, I will substitute the x with the 4. So you will have 5 into 4 under root 4 plus 2. So that will be 42. Okay. So the gradient of the tangent is 42 when the x is equals to 4. To find the coordinate of the tangent, I need the y coordinate as well of that point. So when x equals to 4, put x equals to 4 in the coordinate of that curve. So you will have y equals to 2x square under root x plus 2x minus 1. That's the coordinate of the curve. In the place of the x, put 4. So 2 into 4 square plus under root 4 plus 2 into 4 minus 1. So that will give you 64 plus 8 minus 1. That will give you 71. So the value of the y is 71. Okay. Now I am going to use this point and this gradient, and I will find the coordinate of the tangent. So the coordinate of the tangent will be y minus y1 equals to m into x minus x1. Y minus y1 is 71, m is 42, and the x1 is 4. Okay. So y minus y1, y minus 71 is equals to 42x minus 42 multiply 4, that's 168. So y will be equals to 42x minus 168 plus 71. So y will be equals to 42x minus 97. So this is how you will do the question number 5. Let me show you the answer as well. So you know that the question number 5, exercise 9b, the question number 5, the marking scheme is showing up on your screen. Our answers are right. This is how you will do the question number 5 of the exercise 9b. This is our third episode on this exercise. I hope that this question number 5 is clear to you. In the first part, we found the coordinate of the curve. In the second part, we found the equation of the tangent when the x is equals to 4. So now we are going to solve the question number 6 of this exercise, and on your screen the question number 6 of the exercise 9b is showing up. A curve is such that the dy by dx is equals to kx plus 3, where k is a constant. The gradient of the normal to the curve at the point 1 comma minus 2 is minus 1 by 7. Find the equation of the curve. So this is the question, sir. So very simple. I have already solved this on the board to save the time. So dy by the dx is equals to kx plus 3, that is given. The gradient of the normal is minus 1 by 7 at the point 1 comma minus 2. So what I will do, I will take this, I will integrate both the sides. So here you will get y, here you will have 2x square. The power is increased by 1, and with the same number I divide. So it will become kx square divided by 2. Here you will have plus 3x plus c. So in this, I will put 1 in the place of the x, and I will put minus 2 in the place of the y. So you will have minus 2 equals to k into 1 square divided by 2 plus 3 in the place of x1 plus c. So you will have minus 2 equals to k by 2 plus 3 plus c. So multiply both the sides with the 2. You will have minus 4 equals to k plus 6 plus 2c. So you will have k plus 2c minus 4 minus 6, that's minus 10. So you will get an equation in k and the c. I don't know the value of the k, I don't know the value of the c. But I got an equation in the k and the c, that is k plus 2c equals to minus 10. Okay, then they have told me that the gradient of the normal at the point 1 comma minus 2 is minus 1 by 7. Because I know the derivative here, dy by dx is equals to kx plus 3. So that is the gradient of the tangent, okay? And dy by dx at the point 1, when the x is equals to 1, I put in the place of x, I put 1. So you will have dy by dx equals to k into 1 plus 3, so that's k plus 3. This is the gradient of the tangent. The gradient of the normal is reciprocal and the sign must be changed. So the gradient of the normal will be, you reciprocate this and you put a negative with it. But we know that the gradient of the normal is minus 1 by 7. So minus 1 by 7 equals to minus 1 by k plus 3. Minus minus will be cancelled. You have 1 by 7 equals to 1 divided by the k plus 3. Cross multiply here. So you will have k plus 3 equals to 7. So k will be equals to 7 minus 3. So k will be equals to 4. 7 minus 3 is 4. So now I know the value of the k, that's 4. I will put this k value into this equation. You can see here k plus 2c equals to minus 10. So in the place of the k, I put 4. So that is 4 plus 2c equals to minus 10. So 2c will be equals to minus 10 minus 4. 2c will be equals to minus 14. C will be equals to minus 14 by 2. C will be equals to minus 7. Now I know the value of the k and the value of the c. This is the equation of the curve, and I will put the value of the k and the c in that, and that will give me the equation of the curve. So the equation of the curve will be y equals to kx squared by 2 plus 3x plus c. In the place of the k, I will put 4. You can see here. And in the place of c, I will substitute minus 7. So 4x squared by 2 plus 3x minus 7. This 2 and this 4 will be simplified. So you will have 2 y equals to 2x squared plus 3x minus 7. This is how you will find the equation of this. This is the question number 6 from the exercise 9b. This is my third episode on this exercise. The topic of the exercise is finding the constant of integration. Topic of the chapter is integration. We are solving the course book of the Pure Maths 1. This is ASA levels mathematics 9709, and we are working on the paper 1 of this subject. So let me check, let me show you the answer, sir. So you can see here the question 9b, question number 6, 2x squared plus 3x minus 7. This is the answer, sir. Question number 9, and it's 6 part. So this is how you will do the question number 6. I hope this question is clear to you. So we will go to the next question. The next question coming up on your screen is question number 7. So, my dear students, now we are going to work on the question number 7, and let me show you the question number 7 here. He says the function y is equals to f of x as the gradient function f prime x is equals to 8 minus 2x. The maximum value of the function is 20. Find f of x and sketch the graph of y equals to f of x. Okay, so very simple. See here, the derivative of that function is given 8 minus 2x. This is the symbol for the derivative, and it is given that the maximum value of the function is 20. And so this is basically derivative. F prime x means derivative. So at the stationary point, the derivative is equals to 0. So I will make this derivative equals to 0. 8 minus 2x equals to 0. From here I will get the value of the x. So minus 2x will be equals to minus 8. Minus minus cancel. X will be equals to 8 by 2. The x is equal to 4. So at the stationary point is at when the x is equals to 4. This is the derivative. Okay, so at the maximum value this will be a stationary point. So at the stationary point the derivative is 0. Okay, so from there I got the value of the x. So now I will integrate this f prime x, that means derivative is 8 minus 2x. When I will integrate both the sides, this will become simple f of x, and this will become 8x minus 2x square by 2 plus c. So in the place of x I will put 4, and I know that when x is 4, the value of the function is 20. Okay, so and the value of this function will be 20 when the x is equals to 4. That was given in the question. So this value I just found from here. The maximum value was given. So 20, f of x is 20. When the x equals to 4, 8 into 4 minus 2 into 4 square divided by 2 plus c. So this becomes 20 equals to 32 minus 16 plus c. 2 cancel. So you will get the value of the c. 20 plus 20 is equals to 32 minus 16 is 16 plus c. So c will be equals to 20 minus 16. C will be equals to 4. Okay. Now the function f of x will become 8x square minus x square plus c. The value of the c is 4. So this is the equation of that function. F of x equals to 8x minus x square plus 4. So he said the f of x equals to y. So y is equal to 8x minus x square plus 4. So we know that the turning point of this curve, this function, is at 4 comma 20, because here the x square is negative, the coefficient of the x square is negative, so it's a sad face. Now because he want me to draw that graph, so I already know the turning point of this curve, and I know it's a sad face because this x square is negative. So I will find out the x-intercepts. The x-intercepts, this is the point of the curve. At the x-intercepts, the y is 0. So in the place of y, I will put 0. So that's minus x square plus 8x plus 4. I took the whole thing to the other side. So this becomes positive. X square minus 8x minus 4 equals to 0. Then I apply the quadratic formula. Minus b plus minus under root b square minus 4ac divided by 2a. The a is 1, the b is minus 8, and the c for the quadratic is minus 4. Okay. Then I will put those values. This will become plus 8 plus minus 8 whole square minus 4 into 1 into minus 4. The whole thing under root here, then we have divided by 2. So this will be 8 plus minus under root 64 plus 16 divided by the 2. So you will have x equals to 8 plus minus under root 80 divided by 2. So there are two options. 8 plus under root 80 equals to divided by 2 equals to, that is 8.47. And if you go with 8 minus under root 80 equals to divided by 2 equals to, that is minus 0.47. So the y, so that means the x-intercept is 8.47 comma 0, and the other x-intercept is minus 0.47 comma 0. Then I will find the y-intercept. For the y-intercept in the equation, in the place of x I will put 0. So you will have y equals to 8 into 0 minus 0 square plus 4. Y will be equals to 4. So that point is 0 comma 4. Then I made a sketch. Okay, it's a sad face. Okay, the point is, the curve is going to take a turn on 4 comma 20. Its y-intercept is 0 comma 4. Its x-intercepts are at minus 0.47 comma 0 and at 8.47 comma 0. So this is how you with the free hand you can sketch the graph. So this is how you will do the question number 7, and this question number 7 is showing up on your screen. It requires prior knowledge of drawing a quadratic curve, and it also requires the knowledge of the stationary points. I hope you understand, and if you think you have understood from it, and these three questions, question number 5, 6 and 7, they are helpful to you, please share the link of this video, please like this video, share the link of this video with your friends, with your class fellows, with your junior students, so that they can also prepare these questions. You see, the purpose of these videos is to provide the guidance for those students who are in AS mathematics and their maths is weak. Their basic mathematical skills are weak, and they need step to step guidance. The students who are very brilliant, they don't need this. Um, this is for weak students. So I hope that this video will be helpful to you. Thank you very much, everyone. Have a good night, and God bless you all.